All right, so this is going to be section 2.3 of Math 146. We are going to be finding real zeros of a polynomial. Basically, what we're going to be doing is finding the solutions to the polynomial, if that is possible to do. There are several different methods that could be used to do this. For a standard simple polynomial that might be just a quadratic, your first thought should probably be to factor, or maybe to use a square root property if possible, or to use the quadratic formula. Perfectly fine and acceptable to use all those. It's when the polynomials get a little bit bigger in degree that we have to think of other things. So let's get right to some examples and how we're going to do it. This first part hopefully will be a review. If not, hopefully you'll be able to pick up on it. Let's say that we want to factor so that we can solve the equation f of x equals 2x cubed minus x squared plus 2x minus 3. Now, when it says we want to find the zeros of a polynomial, basically that means we want to figure out when y is 0. And of course, f of x is equivalent to y. So really what we are doing is we are setting the equation equal to 0, since that's what we want y to be. That's what it means to find the zeros. And I guess I should mention the fact that it says real zeros, because you can have what are called imaginary zeros. I typically like to use a different word. I like to use lateral numbers as opposed to imaginary numbers. Um, could probably get into that at some other point in time, probably not during this class. But anyway, most people call them imaginary, so I'll stick with that word for the purposes of this class. Um, okay, so we want to find the zeros. Now it is a cubic function. So my first thought would be, let's see if it's possible to factor, because I don't want to have to use these other methods unless they're necessary. And this one, because it's 4 terms, the first thought would be, well, there's nothing in common, so could I factor by grouping? If you group any two of those terms together and then group the other 2 terms, I don't believe that there's a way for us to easily factor out a common factor and then be left with something that grouping works. So we have to come up with a different method. Um, in this case, I'm going to actually tell you that x minus 1 is a factor. That's not always going to be the case, but I'm going to tell you that x minus 1 is a factor. So we're looking to figure out the other factors. Because I am telling you that x minus 1 is a factor, and we'll eventually get into how you can actually figure that out in just a second, we want to go ahead and factor the rest of this again, if possible. So we're going to review, and again, I hope this is review, how to do long division of polynomials. Also, we're going to review synthetic division of polynomials, and we're going to show that they basically give you, well, they are going to give us the same thing in this case. So let's go ahead and set up a long division. So long division, you're going to take the function, which is 2x cubed minus x squared plus 2x minus 3, and we're going to divide that by x minus 1. So hopefully the the whole long division symbology here, symbology, it's not even a word, I don't think, looks right to you guys, looks like something you've seen before. It's just like doing long division with numbers, except that you're using polynomials. So my thought process has always been to look at the divisor, the number on the outside, which is x, um, the leading term, excuse me, is x, and see what you would have to multiply that to get the first term of what's underneath of the division symbol. So in order for me to get the 2x cubed from here, I would have to multiply this x here by 2x squared. Okay, so I'm going to write that up here, 2x squared. And now what you're going to do is you're going to distribute the 2x squared to both x and the minus 1, and then write them under the appropriate degrees underneath. So 2x squared times x gives me 2x cubed. Okay, that kind of has to happen every single time. That has to match that first term. And then 2x squared times minus 1 is going to give you minus 2x squared. And if you remember from long division, you would now subtract what you have. So 2x cubed minus 2x cubed has to go away. It does. And then we've got negative x squared minus a negative 2x squared, or basically plus a 2x squared. So negative x squared plus 2x squared is plus x squared. Bring down the next term, and then repeat the process. What do I have to multiply that x on the outside to get x squared? I would have to multiply it by x. So now we'll have x squared distributing, and then minus x, and then we subtract. So again, the x squareds go away. I've got 2x minus a minus x, which is 2x plus x. That leaves us with 3x. And then what do I have to multiply by x to get the 3? Excuse me, 3x is going to be a positive 3. So then we'll have, oops, forgot to bring down the other term. So then we'll have 3x minus 3. And the nice thing is, since those are identical, we have 0 as a remainder. So what that has done is that has given us the other factor, 2x squared plus x plus 3. And then that leaves us with a quadratic, which hopefully we can factor by normal methods. If not, then there are other ways to do it. But let's go ahead and see if that will work. So I've got x minus 1. If this factors by normal methods, that's going to have to be a 2x and an x. I'll have to have a 3 in here somewhere. In order to get that 1 in the middle, I am pretty sure that I would have to have a 3 here and a 1 here. But the problem here is that in order to make that a positive 3 on the outside there, both of these two numbers have to be either positive or negative. I do not believe that we are going to be able to factor the 2x squared plus x plus 3 any further by normal methods here. So I'm going to go ahead and erase. In order to actually factor that 2x squared plus x plus 3, we might have to go quadratic formula here. Let's see what that would give us. So x equals negative b plus or minus the square root of b squared minus 4 times a times c. And if you already noticed what's going to happen, all over 2a. On the underneath of that square root, I'm going to get 1 minus, what's that going to be? 1 minus 24. It's going to be a negative 23, which means that the other two roots that we would get out of this would be non-real, because you can't take that square root of the negative number in the real number system. So the only real root to this thing would actually be x equals 1. That would be the one real 0 of this thing. I gave you, in this case, what the real 0 was. If you needed to test and almost guess in this case, because I haven't given you the other methods yet, you could have guessed 1, plugged 1 in for f of x, and seen that you got 0. That's kind of taking your chances on a guess there. Again, we're going to come up with other methods here. All right, now let me show you that synthetic division will yield the exact same thing. So for those of you who remember synthetic division, this is actually pretty cool. It basically takes the same process that we just did and just shortens the amount of writing that you have to do. So since 1 we know was going to be a solution, we put 1 up here. I kind of put it in this little box. Everybody does it slightly differently, but that's where I put the 1. Then what you do is you write the coefficients of the polynomial that you're dividing. So that would be a 2, a negative 1, a 2, and a negative 3. And then I put a little bar down here. And the process for synthetic division says I'm going to bring down the first number. So I'm literally just going to bring that down underneath here and write 2. Then what you do is you multiply your 1, 0 there, which is number 1, times 2, and then you bring it up here. So multiply here, and then bring that number up here. And then what you do is you simply add the column together. So negative 1 and 2 is 1. Repeat the process. Multiply, bring it up, So that's 1, add, multiply, bring it up, and add. And because I have a 0 on the end there, that means that this is a factor with no remainder. What you have here is this is the remainder column. This is your constant column. This is your x coefficient. This is your x squared coefficient. And if it kept going, it would just go in order. The next one to the left would be x cubed, x to the fourth, and so on. So what that gives us is 2x squared plus x plus 3, which you can see is exactly the same thing that we got there. And we already know that that doesn't factor any further. All right, so we have done long division and we have done synthetic division. Technically, you can do whichever one is easier for you. Synthetic division works much easier when it's linear factors like x minus 1. It also works if you have other factors, but those are a little bit more challenging to do. So long division has its purpose as well. If you can utilize the synthetic, I strongly suggest doing that. But now let's say we're given a polynomial and we aren't exactly sure what the factors are. We can't just look at it and determine it. First of all, hopefully we all know that whatever the degree of the polynomial is going to be the number of solutions, the number of zeros that you have. Whether they are real solutions or non-real solutions is up for determination, but you at least know that's how many solutions you have. So for our second example, once again, we're going to go with a polynomial that's a cubic. So it'll be 2x cubed plus 11x squared minus 7x minus 6. Once again, this does not look like grouping will work to factor this. So you could just start guessing if you wanted to values if you want, and maybe you'll get lucky and guess the right one off the top. But there is a method to actually figure out all the possible zeros, the real zeros that you could have. Just to make sure that we understand this, and this will come back up later, if you have imaginary zeros, they have to come in pairs. So in other words, there are 3 zeros to this cubic function. If there were going to be imaginary zeros here, then there would be 2 of them, leaving 1 real. You cannot have just one imaginary solution. They come in pairs. So basically, if you have an odd degree, you will have at least 1 zero that's real. Maybe more, but at least 1, because there's no way for you that 1 left over to be imaginary. All right, but here's how we do it. If this is written in standard form, and it is because it's in descending order of exponent, this right here is typically what is called the Q value. This right here is called the P value. So the P is your constant, the Q is your leading coefficient. Doesn't really matter if you know the letters here so much. What does matter is that you understand that when we look at all the possible solutions, you're going to take every possible factor of P and divide it by every possible factor of Q. So what do I mean by that? Well, 6, I'm not worried about the negative sign right now. 6 has factors of 1, 2, 3, and 6. So P has 1, 2, 3, and 6 as factors. 2, of course, has 1 and 2 as factors. Well, I need to take every value of P, so 1, 2, 3, and 6, and divide it by every value of Q, and that will give me a list of all the possible factors. Now, the one thing you do have to consider is the fact that these could be positive or negative. So let's just go in order. Let's take the 1 from the P value and say, okay, I'm going to divide 1 by the 1 over here, and I'm going to divide the 1 by the 2 of the Q. But you have to consider that they could be positive or negative. So we're going to have a bunch of different factors here. Okay, now let's move on to the 2 value of the P. So we've done the 1, now let's do the 2. So that could be 2 over 1 or 2 over 2, plus or minus. Now let's move on to the 3. plus or minus 3 over 1 plus or minus 3 over 2. And then we'll do the 6 last here. Doesn't have to go in that order. We just did it that way. Plus or minus 6 over 1 and plus or minus 6 over 2. Now what you should do is you should probably go ahead and reduce the ones that you can because you don't need the repeated values. For example, I've got plus or minus 1 here. Perfect. Got plus or minus 1/2 from the second one. Okay, the next one is plus or minus 2. The fourth one here is plus or minus 2 over 2, which is the same as plus or minus 1. I don't need to rewrite that. So we'll move on to the next one. Plus or minus 3. The next one, plus or minus 3/2. The next one, plus or minus 6. And then the last one, plus or minus 6 over 2, but that's plus or minus 3. Again, I already have that. I don't need to repeat it. Still, I have 1, 2, 3, 4, 5, 6. I have 6 values, the positive and negative. So I have 12 different possibilities for things that could be the zeros of this function. That's a lot of different possibilities to check. The nice thing is once you find the first one, then you can apply long division or synthetic division, whichever works best for you, to start working out the other ones, and it becomes a lot easier. So in this case, it is kind of a guess and check. And I tend to go for the smaller values first because I think it, or the easier values, excuse me, because I think they're easier to plug in, especially if you're trying to do it quickly without using a calculator or something like that. So my first thought would be, let's try 1. And if we plug a 1 into the original function, that would be 2 plus 11, which is 13, minus 7 minus 6, which is minus 13. So actually 1 works. That was quite lucky in this case that we got 1. So 1 gives us a solution. So f of 1 is 0. That is perfect. That means that x minus 1 is going to be a solution. So now we can use, again, synthetic division or long division. I think synthetic will work out very nicely here. So I'm going to do that. If you prefer long division, go for that one. So over here, I'm going to put 1, and then I'm going to write 2, 11, negative 7, negative 6. Let's see, bring down the 2, multiply it by the 1, that goes here, add. Multiply that 13 by the 1, that goes here, add. Multiply that 6 by the 1, that goes here, and add. And like I was hoping, we have no remainder. So remember, this is your remainder, this is your constant, that's your x squared. So what we have for our remaining factor is going to be 2x squared plus 13x plus 6. And then if that can factor, and I do believe this one actually does factor, then we don't need to go through this whole process again. You could start taking these factors and do the whole, 6 over 2, which we have already done, and start plugging them in. But we don't need to do all that because this one, in this case, actually does factor 2x and x. Everything has to be positive. So that 6 is going to have to go there, and the 1 would have to go there. Now that would give me a 12x and a 1x. Yes, that works out to be the 13x in the middle. So my final solution to this for the factors, is x minus 1, 2x plus 1, and x plus 6 equals 0, which means that either x equals 1, x equals negative 6, and in the middle one you have to do a little bit of work. If you set that equal to 0, you would subtract 1, divide by 2, so x would be negative 1/2. And I'm kind of glad that I didn't go through the process of the p over q. I would not have plugged in 1/2 or 3/2 until close to the end, just because they're not as easy to deal with. I would have gone through 2, 3, 6, and then all their negatives first. So probably a good thing that we went ahead with the synthetic division. So those are your solutions for your zeros. All right, we are actually only going to do one more example, and we're actually not going to completely do the example because it takes a really long time. But I want to show you This will be example 3. I want to show you how the process would work and what your best methods might be in this case. One thing I do want to touch on before I get to the example, this is not actually going to be part of our example. Let's say that you had something where you needed to find the zeros, and this probably isn't going to work out. I'm just making this up off the top of my head. X cubed minus x plus 4, and we wanted to divide that by x minus 1. So the problem is I don't have every single possible degree term underneath of my division symbol. I'm actually missing an x squared term. You can't actually do it the way that I have it set up right here. You have to basically include a placeholder for that x squared term. So what you would have to do is in the place here, you would have to add a 0x squared. So it would actually come out to be x minus 1, and then here it would be x cubed plus 0x squared minus x plus 4. You have to have a placeholder for everything. The way I like to try and say this is, say I wanted to divide 1209 by 71. I'm not doing the process, but you can't leave out that 0. You can't just say, oh, I'm going to do 71 divided by 129. That doesn't work. You're leaving the 10 spot out. Well, here, if we didn't have this piece, we'd be leaving the x squared spot out. So you need to include that, even though it wasn't written in the original equation, because you don't usually write the 0x squared. That placeholder needs to be there. That goes for whether you do long division or synthetic. You'd have to have that 0 as in the place of the x squared for your synthetic division as well. All right, so let's go ahead and do example 3. This will not happen for example 3. I just wanted to bring that up just in case you see this. So f of x in example 3 here is going to be x to the 5th minus 7x to the 4th plus 19x cubed minus 37x squared plus 60x minus 36. That's a big one. All right, well, there's no way I'm looking at that and thinking I'm going to factor it easily. It's an x to the 5th, so it's got a 5th degree, which means it's going to have 5 solutions. Again, I could have some combination of real solutions and non-real solutions. I know I will have at least one real solution, though, because it's an odd degree. I could have more. I could have all 5 of them being real. I could have 3 of them being real. There's a bunch of possibilities here. The only good thing is that our p-value is 36, but our q-value is 1. So every time I divide something, I'm dividing it by 1, which is nice. So p over q here is going to be plus or minus 36 over 1, plus or minus 18 over 1. Let's see if I can not leave out any factors here. Plus or minus, let's see, 12 over 1. Plus or minus 9 over 1. Plus or minus 6 over 1. Plus or minus 4 over 1. 3, 2, and 1. Whew, okay, that is an awful lot of possibilities there. 1, 2, 3, 4, 6, 9, 12, 18, and 36. Yeah, I think that are all the factors of 36. So, again, and I wish I could tell you there was some easier way. There isn't. Start plugging in values and hope that we get one quickly. I start with the smaller ones. I think they're easier to do. So let's start with 1 and see what happens. If you plug in a 1, let's see what we get. So if you plug in 1, 1 minus 7 is negative 6, plus 19 is 13. Oh boy, minus 37 is going to be negative 24. Plus 60 is 36, minus 36 is 0. How about that? All right, so that worked out really nicely. I'm glad we don't have to do that for a lot of them, but the process does repeat. So, all right, well, we've got 1. Yeah, let's do synthetic. I think it'll probably be the easiest. So 1 goes here. So we got 1, negative 7, 19, negative 37, 60, negative 36. Bring down the first one, multiply it by 1, and put it here. Add. Multiplying by 1, put that there, add. Multiply by 1, put that there, add. Multiply by 1, put it there, add. Multiply by 1, add. All right, so now we are left with, so we know x minus 1 is one of our factors. We are now left with, let's see, that's the remainder, constant x squared, x cubed, x to the 4th. So we are left with x to the 4th minus 6x cubed plus 13x squared minus 24x plus 36. Again, I don't see any way to do this other than to kind of keep guessing. So what you might want to do here, and again, because you got to start off with the same things. You still got a 36 on the end, and you still got a 1 for a coefficient. So all the same possibilities are in play. I would start off with 1 again. Why is that? Because you can have a repeated factor of x minus 1. It could happen multiple times. So I would start off with 1 again and see what that gives us. So if you were to plug in 1, you'd have 1 minus 6 plus 13 minus 24 plus 36. Let's see, what is that? Negative 5 plus 13 is 8, minus 24 is negative 16, plus 36 is actually going to give you 20, which is not 0. So in this case, that one does not work. Okay, so 1 is not going to be a factor. So then you got to try a different value. You could try negative 1 and see what happens there. If you try negative 1, I'm just going to tell you right off the bat, is not going to be a factor. So you could keep trying all of these different possibilities until you eventually get to 1. The next factor, and unfortunately, if you try 1, negative 1, 2, negative 2, the next factor is actually going to be 3. So you would try all of them, and then you would get to 3 and say, oh, 3 does give me 0 there. So then x minus 3 would be a factor. So then you would do 3, and then you would have 1, negative 6, 13, negative 24, 36, and then repeat the process. And because 3 is a factor, you would get 0 on the end, and then you would go from there and you'd have a cubic left over, and the process would just keep repeating. So again, I'm not going to finish that one. That's not something that's likely to happen too often where you have a polynomial that big, but that is what you would do in order to figure out your factor. So biggest takeaway from this is the process of long division, the process of synthetic division, and how to find all the possible factors, the real factors of a polynomial. It's the P over Q method, where P is your constant and Q is your leading coefficient. You got to take the positive or negative of them and basically start trying values. Again, I wish there was some shorter process for that. To do it by hand, there's not one that I am aware of at this moment in time, so that's what we're going to deal with. All right, that should end this video and this lesson, so you should be good.